last session for today, right? So in the next 35-ish minutes, Alexandre and we will share why API management is a must when you are dealing with intelligent applications which use LLM models, such as Azure OpenAI's ChatGPTs. So my name is Andrei. I work in Azure API management as a product manager. I mostly was working on these features that I will present today. And later, Alexandre will join me. He works in the EMEA GBB team or Global Black Belt team as a technical specialist. So I guess you're all familiar with Azure API management already. There is no need for further introduction. But in short, Azure API management allows API providers to secure, manage, and publish APIs. And when you think about LLMs, LLMs are just yet another API. There are specific requirements that I will share when it comes to LLM APIs. But in general, you put API management as a gateway between your applications and your APIs. So why GenAI? AI just sets a stage for a lot of conversations we're having with customers and partners today. It redefines the way how people consume or interact with applications, but it also changes the way how you build those applications with these new intelligent capabilities that LLMs provide. And of course, in the center of this kind of revolution on how you build your applications is Azure OpenAI Service. Azure OpenAI Service provides access to large language models such as GPT-4, GPT-4 which was introduced recently at Build, GPT-3.5 Turbo, and so on. And these models generate human-like text and images that you can then use in your applications. And there are three main things that you need to think about when it comes to Azure OpenAI. First is tokens. Tokens is the main currency that you have when it comes to large language models. So if you're not familiar with it, but when you send a prompt to your model or when you receive a completion from the model, text is got tokenized. So each chunk of text represents a token. So the longer your prompt is, or the longer its completion that you receive from the model, the more tokens you consume. And that's why tokens are important. And when it comes to Azure OpenAI and other models, you have quotas assigned to models, assigned to model deployments, assigned to your subscription to use with Azure OpenAI service. And this quota is expressed in tokens per minute. So that's kind of your main resource that you use when you send requests to the model and you receive responses from the model. And also tokens is the main thing that you're paying for. So if you're in a pay-as-you-go model, you're paying for tokens, or if you're going production and you want to have some sort of reserved capacity for your applications, that's where you go with so-called provisioned throughput units or PTUs, where you can think about it as just a reserved capacity for your intelligent applications. But even then, you still think about PTUs equivalent in TPMs, because again, that's one of the most important things. And as I mentioned, it's just another API. So you either call it through the API request directly, or you use one of the many SDKs which are available out there. And Azure makes it very simple for you to start using LLMs. So you have an application, you just import SDK of your choice, you deploy Azure OpenAI service, you deploy a model, let's say GPT-4, you get the API key, you put it into your application, and you're good to go. You can send requests, you can receive completions, you can build intelligent experiences for your users. But what if you want to scale? What if you want to add more applications? What if you have, I don't know, like 10 different development teams that want to use these LLM models? Or on the other hand, like what if you want to have multiple OpenAI endpoints? Let's say you purchased a PTU that I mentioned before, and now you have PTU on pay-as-you-go. You want to use all of the endpoints that you have. Or you have an OpenAI endpoint in Canada, and you have an endpoint in Europe, and now you want to load balance somehow between multiple endpoints. So, and that comes with certain challenges. Now you need to track token usage. Like you have multiple teams, you have multiple applications, and as I mentioned, tokens are important, which means that you need to understand like this application B, how many, or application A, how many tokens were consumed? This application B, how many tokens this team consumed? You also have multiple OpenAI endpoints, as I mentioned. Probably if you're using PTUs that you pre-purchased, you want to use PTU endpoints first and then fail over to pay-as-you-go endpoint. Now, authentication and authorization. Like, as I mentioned, you have an API key associated to your OpenAI endpoint, but now you have like tens of different applications. You don't want to share this key, or even if you want to share this key, how should I do it securely, right? So there are certain challenges with when it comes to security. And then token limits. Again, you have tokens per minute per deployment. Now you have 10 different applications. What if my application A consumes all of the tokens? Which means that application B and application C and other teams, they're basically breaking the experience for their customer, or for their users of their applications, because now you cannot call the OpenAI endpoint anymore because you're throttled. And that's when where Azure API management comes into play. So during build, we introduced a set of GenAI Gateway capabilities that address this specific set of challenges. So first is we introduced an Azure OpenAI token metric policy. This policy uses the application insights service that you have already onboarded to Azure API management. And with a simple policy, you just configure a namespace, you configure a number of dimensions that you want to use to track your tokens, token usage. So in that particular example, we are tracking the subscription ID, which is typically used to identify an application in Azure API management. And then you can just go back to application insights and you can see the breakdown that application A consumed that amount of tokens and application B consumed another amount of tokens. Now, load balancer circuit breaker. This is something that not only useful for OpenAI, but this is specifically useful for the PTU and pay-as-you-go options that I mentioned previously. We had them in preview for a while, and we GA'd them during build. But we also introduced a couple of new capabilities. So before that, load balancer was only supporting the round-robin algorithm, but now we added the weighted and priority-based load balancing. So in that case, in the case of OpenAI use case, you can now say that, oh, my PTUs and endpoints should be prioritized first, and then if they're throttled, if you receive 429 from those PTU endpoints, you can now fall back to the pay-as-you-go option. Now, when it comes to authentication authorization, that is pretty concerning problem. But with Azure API management, you can now configure managed identity authentication from APIM to OpenAI. So in that case, you don't need to store or share your keys anymore because we do authentication in Azure using managed identities. And on your application side, they can still use subscription keys to do authentication for APIM, or you can go even further and configure the JWT token validation using policies. And now you can say that if there is a specific claim in a request or in a token, this application can access specific deployment in Azure OpenAI. And token limit. So that's similar to kind of a rate limiting that you have for regular APIs, but in that case, we actually think in terms of tokens per minute. So with this new policy, which is GA now, you can assign tokens per minute limits for your applications based on subscription key or any other, another arbitrary key, because we support policy expressions. We also make sure that if you want to be extra strict with your TPM limits, we can also estimate the number of prompt tokens. So if you're sending a prompt to the model, we take this prompt, we tokenize it, we understand how many tokens were consumed in this prompt, and then we increase the counter. And if we understand that it already exceeds the TPM limit that you specified for a specific application, we do not send this request to OpenAI. And the last one is something that is, I would say, kind of experimental right now. That's why it's in preview, is Azure OpenAI semantic caching policy. Just like with regular APIs, you use caching to improve latency, to improve performance, and there is a similar concept in LLM world, but in that case, you're not caching the exact request, but you're caching the semantically similar request, which means that, for example, if I'm asking for, I don't know, a model to tell a story about Azure API management, And then the second prompt is going to be tell me a story about APIM. We will understand that these are the similar requests, and in that case, in the case of a second request, we will return the completion from the Redis cache. And now let me hand it over to Alexander, who will show you how these policies work in action.
Thank you, Andrei. It's such a pleasure to be here with you all. The nice thing about this event is, to meet so many people. Complicated thing is that we have so many good moments. Then now having a serious face here doing the demo, it will be very difficult. So Andrei just showed a lot of features from API management, and this will be the last demo of the conference. So bear with me in this last demo. We will see these features in practice. So I will start here to switch to Azure portal, okay? The Azure portal that we know. And I have an API management instance already here set it up. And I will create a new API for my OpenAI service that is already provisioned. I will start just to pick from the list. You can see that I have a lot of different API services already provisioned. I will just pick one from the list. Then I will select the API version for OpenAI. Of course, AI is a fast evolving topic. There have been new API versions being added. Generally, as a rule of thumb, I will select the last stable one, okay? As is the case here, that is the default one that is selected. Then I will give it a name, okay? It can be just OpenAI or can be, the name that you prefer. And then there is this option that we could improve the SDK compatibility, because most of the SDKs for OpenAI, they are expecting to have OpenAI in the end of the URL. So with a single click, we get that. And as you know, API management has the concept of products, and we can include the API in different products. And this wizard has this nice experience that we can select here the different products where we want to include this API on, okay? And then the fun part begins, to configure the policies for the API automatically. So here we have two policies already defined, the policies that Andrei explained, and the team is working to add more policies here in the future. So it's really easy. We just go here, for example, for this one, to manage token consumption. We will define a rate limit for this API. In this example, I will put 500 APIs. And I identify the consumer with these two different options, by the subscription key or with the IP address. I will just use the subscription, and the policy has this power of estimating the tokens automatically, okay? So it doesn't need to get the response from the LLM. It estimates the tokens when the request comes to API management. Optionally, we can include headers that might be very useful, for debugging purposes. And then we go to the second policy, that is to track token usage. Very important for us to understand who is consuming the LLM, how many tokens are being consumed. So API management integrates with the application insights out of the box, and we are leveraging that same capability here to measure the tokens. So we will see here a list of App Insights instances. By default, this is the one that is configured, and we can add additional dimensions so that we can then track these different dimension data with the custom dimensions from App Insights. So then I will review, and this note here that we will use the Microsoft Entra ID authentication to authenticate between API management and Azure OpenAI. This means that the key, the secret from OpenAI, will not be used, okay? We will just use the built-in managed identities provided by Azure. So it's like a keyless approach, okay? Very good for zero trust security approaches. So we will do create, okay? And then it should take some seconds and we will see the API appearing in the portal, okay? Maybe some connection issue. I will just refresh the browser here. I didn't took the chicken way. It was like a really live demo, so it happens, right? So things to note here, if I go to the settings, by default, when we add a new API, it uses the default header name, but here changes to API key header name, just because the SDKs are sending this header name by default. And we don't want to have any change on that behavior, okay? So we want to plug API management in the middle without any changes. And then, as we can expect, if we go to the policies, we want to see here the policies that were added automatically with this wizard, okay? So we have here the engineers that work on these features, so they deserve some love from us. Switching gears to Visual Studio Code, okay, that besides the Azure portal is an environment where we stay a lot of time developing new APIs, working with, with the logic apps as we saw in previous sessions. So it's becoming like an IDE for all the tasks that we need. And the API management service provides an extension for VS Code that is very useful, for example, for debugging the API, debugging the policies, okay? And this is something that we can use. I will not show that here. I will show another thing that is the power to use Jupyter notebooks, okay? I will just hide here this panel to do experimentation on OpenAI and to do experimentation on the APIs that are being provided through API management. Because from my experience, for you to move into production with any kind of AI workload, you need to know exactly what you are doing. So you need to have this kind of labs, experimentation, to tune in the policy, to test it, and then to move to production with confidence. And Jupyter notebooks, together with Python code, is really powerful for that, okay? For this kind of experimentation. And then there are a second thing that makes sense, that as we have seen in previous sessions, Python with AI workloads is everywhere. So it's the Python SDK is the most used by far SDK when we are using OpenAI. So imagine that you have exposed the API through API management, and you want to really make sure that works out of the box seamlessly with an OpenAI SDK. So a good way to do that is to leverage this kind of Jupyter notebooks. So the way it works, okay, is that basically we have here a simple script that we can use GitHub Copilot to build, but honestly it's something simple that I will just hit play here. And in this example, just to have fun, it's a sarcastic bot, okay? So we'll have nice sarcastic answers from the bot. And we want to test the rate limit. So everything is going good. We have green signs, but all of a sudden, we start to have the 429 error, okay? Because we hit the rate limit that we previously defined. And so, yeah, we get some rate limit. And if we want to really make sure what's happening, okay, we can use the pandas functionality of Jupyter notebooks and having this kind of graph, okay? That clearly identifies the consumption of the API, and we reach the rate limit, and then we have this 429, okay? And in the previous example, I didn't use the Python SDK. It was a direct HTTP call. And now I will use the Python SDK. As you can see, the code is really simple. And it has a little bit different behavior because the retry mechanism is part of the SDK, okay? So if you don't understand the difference, you'll use the SDK and you'll never get a 4 to 9 just because the SDK handles the retries for you, okay? Now we want to see the metrics and we want to track the usage of the metrics. And here, just to highlight this policy configuration here, so we will use this policy and we have these different dimensions configured, okay? I will hit play and basically I will send this information with application insights. And what I'm doing here is to simulate this behavior with 3 different subscriptions so that I can go into application insights and see this kind of report, okay? So I loaded this previously. As you can see in the bottom, we have 3 different subscriptions, okay? And we can see the dimensions for each one of them. Imagine that the subscriptions are different departments within your company, so you know exactly each department uses OpenAI. And then you can use like a chargeback, showback kind of mechanism so that you can tell them what they are using in terms of OpenAI. Subscription is one of the dimensions. We can use product, we can use a lot of other dimensions to have this kind of visibility. And then another example will be the load balancing, okay? Andrei explained that in a lot of circumstances we'll have like different OpenAI instances, maybe in different regions. Maybe we want to use a PTU and another pay-as-you-go if the PTU is without resources. So API management includes this load balancing. That is not a policy, okay? Is a built-in functionality part of the back-end concept. That simplifies a lot the configuration of APIs, as we can see in the policy. And we can achieve that with a simple bicep configuration, okay? That handles circuit breaking as well. And we will be adding here priorities and weights so that we can have not only round robin, but having different kind of distribution mechanisms, okay? So if I will play here, okay, to test this out, what I'm expecting is to see a return, again, the sarcastic bot response, and I have 3 regions here configured, okay? And if I continue to hit play, now it's with the round robin, I will see France, now UK, and now I will see another region, and I can play with this just to validate that the API is working. I'm using here the API management tracing functionality within this Jupyter notebook. And with this, okay, I can see the, oh yeah, I have the token has expired, so I have to go a little bit above, sorry for this. Again, a live demo. I think is this one, to get the token. Should work now. Yeah. So the tracing JSON that we can get from the Azure portal, I can get it from here automatically. And if I search for like a pool, okay, I can understand where the request has been forwarded and understand what was the behavior of this exact backend. And I can do the same for the policies in order to understand what was the behavior of the policy. Okay? And just to conclude this part, if I want, you know, to have like a test run and to have different results, here it will do, you know, a bunch of calls, and it's easy to understand that it's like a round robin between the different regions. And again, here I can see like a plot of the results. And without surprises, I can see that UK has the least response time, is the fastest one. It will be strange if that was not the case. Then for the semantic caching, okay, we have the policy for semantic caching, where we can configure the threshold for proximity, and embeddings, really simple policy to configure as well. And then if I hit play, what will happen is that the first invocation should take some time, and then the next invocations will be pretty fast, okay? What's very interesting here is that what I'm sending in the prompt is not the same question, okay? I'm doing like a random, different questions, but all the questions are related to the same thing. So in terms of proximity, they are very similar. So the semantic caching policy understands that is part of the same question. And as I can see here then, if I again see this is in a nice chart, I can see that the response time is much better when I use the semantic caching. Not only that, I'm saving a lot of tokens, because just the first request hit the OpenAI endpoint, the other ones were cached automatically, okay? So just one more thing, and this relates with the event that from yesterday from Apple. So they announced that they will use GPT-4o as well. So I thought that would be nice to have also a demo on GPT-4o, just to say that API management is prepared to work with this model, the latest model as well. That means not only sending text, but sending things like pictures, okay? So I use this, this meme that we built it here just to make some fun. It is not raining today, but it was raining yesterday. And if I send this picture, okay, you can see here that we are sending a base 64 encoding of the picture, and we can ask to the model, is this fun or not, okay? And the GPT-4o should provide like a fun interpretation of the meme. Okay, so identifies that API management helped to solve the problem. Okay, identify how to do token usage and provide that. So all these labs, they are provided in this open source repo. Okay, that you can use and extend according to your needs. And we showed some of them, but there are plenty of other labs that you can reuse, okay? Just highlighting here this vector searching, I think might be very interesting for the typical RAG use case, where you'll use the OpenAI API, but also APIs like from AI search and other kind of APIs, okay? Then we didn't discuss here a lot the self-hosting capabilities of API management with the self-hosted gateway, but local models and SLMs are being used a lot in the enterprises, and it's a good use case as well to use the API management self-hosted gateway on premises or in another clouds together with SLM models like Py3, okay? And this lab explores that concept, and there is then another one of my favorites, the function calling, where we can call, in this case, is an Azure function, can be a logic app, but the orchestration between calling these different APIs is provided by API management. And the nice thing is that with the power of application insights, we'll have end-to-end traceability on these different API invocations, okay? So that we are confident about how many APIs were invoked and how, okay? Just to conclude this part, there is a lot of repos here that I include here in these other resources, and just to highlight here a work that has been done with my team as well. That is, when we are confident to move to production, sometimes having like the landing zone and a reference architecture helps, okay? So Mosaif is leading this work, and it's another repo that is shared on GitHub, ready for you to use. The links will be provided in the slide, and back to you, Andrei.
Thank you. Go back to slides. Yeah, so to get started with everything that we showed today, and what we discussed today, we have a separate section in documentation of Azure API management dedicated fully to OpenAI. So head there. We also have a building blocks page where we have a lot of different smaller pieces that you can reuse if you are building intelligent applications, starting from load balancing across multiple OpenAI endpoints to building RAG, building intelligent applications using RAG pattern, and so on. As Alex already mentioned, there is a great way to get started with the Gateway Labs that he showed with this repo. We also have a sample application that represents a simple chat application that uses OpenAI and also uses all of the policies that we discussed today. And we have a GenAI Gateway Accelerator if you're serious about building intelligent applications and you want to have some understanding of the best practices on how to use OpenAI and APIM. There is a landing zone that can help you with that. And one more survey from Azure API Management team. If you are thinking about starting building intelligent applications or you're already building applications that use LLM, we are really interested in talking to you and getting your experience and understanding your challenges when it comes to building intelligent applications with LLMs. So it's a very short survey. It's literally 4 or 5 questions. Take a picture, take the survey right now or at home. We will be very interested in talking to you. Thank you and enjoy your safe travels home.